Hello students, today we will discuss new chapter, that is Laplace transform and inverse Laplace transform. So what is Laplace transform? If f of t is a function of t defined for all t greater than equal to 0, then integration 0 to infinite e raised to minus st f of t dt is defined as Laplace transform of f of t, provided the integral exists and is denoted by Laplace of f of t. So f of s is equal to Laplace of f of t is equal to integration 0 to infinite e raised to minus st f of t dt. So this is definition of Laplace transform. So basically Laplace transform converts t domain into S domain. So our final answer will be in the form of S. Now let us discuss Laplace transform of elementary functions. So first function is 1. So Laplace of 1 is given by integration 0 to infinite e raised to minus st into 1 dt. Because Laplace of f of t is given by integration 0 to infinite e raised to minus st f of t dt. Okay. Now what is integration of e raised to minus st with respect to t? So it will be e raised to minus st divided by minus s, because coefficient of t is minus s. Okay, and limits are 0 to infinite. Now first of all we will put upper limit, that is infinite. So it will be minus 1 by s is common, in bracket e raised to minus infinite minus e raised to 0, because lower limit is 0. So upper limit minus lower limit. Now what is the value of e raised to minus infinite? E raised to minus infinite is 0. And what is the value of e raised to 0? It is 1. So if we simplify this, then final answer is 1 divided by s. Therefore we can say that Laplace of 1 is 1 by s. Now let us discuss Laplace transform for the function t raised to n. So Laplace of t raised to n is given by integration 0 to infinite e raised to minus st into t raised to n dt. Okay. Now suppose st is equal to x. Therefore t is equal to x divided by s. Therefore dt is equal to dx divided by s. Now we have to check that whether limits are changing or not. So if t is equal to 0, then x is also 0. So lower limit will be 0. And if t is infinite, then x is also infinite. Therefore upper limit is infinite. So limit will remain same. Integration 0 to infinite e raised to minus x, because st is x and t is x divided by s. So x divided by s whole raised to n, and dt is dx divided by s. Therefore here we will write down dx divided by s. Now here we have to take integration with respect to x. Therefore s raised to n into s will be a constant. Therefore this can be written as 1 divided by s raised to n plus 1 integration 0 to infinite e raised to minus x into x raised to n dx. Now we have studied about gamma function. So gamma of n is defined as integration 0 to infinite e raised to minus x into x raised to n minus 1 dx. Therefore by definition of gamma function, this can be written as gamma of n plus 1 divided by s raised to n plus 1. Now if n is a positive integer, then we know that gamma n plus 1 is equal to n factorial. Therefore Laplace of t raised to n is defined as n factorial divided by s raised to n plus 1, because we can replace gamma n plus 1 by n factorial if n is a positive integer. Now let us discuss Laplace transform of exponential function, that is e raised to minus at. So Laplace transform of e raised to minus at is given by integration 0 to infinite e raised to minus st into e raised to minus at dt. which can be written as integration 0 to infinite e raised to minus in bracket s plus a bracket complete into t dt. Now we have to take integration of e raised to minus s plus a t with respect to t. So which can be written as e raised to minus s plus a into t divided by minus s plus a, because here coefficient of t is minus s plus a and limit will be 0 to infinite. So minus 1 divided by s plus a is common. First of all, we will replace t by infinite, so here it will be e raised to minus infinite minus e raised to 0, because here lower limit is 0, so we will replace t by 0, so it will be e raised to 0. Here we have to note that s plus a is positive, therefore s plus a is positive, therefore s greater than minus a. So here e raised to minus infinite is 0 and e raised to 0 is 1. So if we simplify this, then it will be 1 divided by s plus a. Therefore Laplace transform of e raised to minus at is equal to 1 divided by s plus a, where s greater than minus a. Now let us discuss Laplace transform of e raised to at. So Laplace transform of e raised to at is given by integration 0 to infinite e raised to minus st into e raised to at dt, which can be written as integration 0 to infinite e raised to minus common in bracket s minus a into t dt. Now integration of e raised to minus s minus a t with respect to t will be e raised to minus s minus a t divided by minus in bracket s minus a, because their coefficient of t is minus in bracket s minus a and limit will be from 0 to infinite. Now here minus 1 divided by s minus a is common, and first of all we will replace t by infinite, then we will replace t by 0. So first of all here we will get e raised to minus infinite minus e raised to 0, because lower limit is 0. Here s minus a is greater than 0, therefore s greater than a. Okay, now what is the value of e raised to minus infinite? It is 0 and e raised to 0 is 1. So if we simplify this, then we will get 1 divided by s minus a. So Laplace transform of e raised to at is given by 1 divided by s minus a, where s greater than a. Now let us discuss Laplace transform of sin at. So Laplace transform of sin at is given by integration 0 to infinite e raised to minus st sin at dt. Now here we will use this formula, integration e raised to ax sin bx dx is equal to e raised to ax divided by a square plus b square in bracket a sin bx minus b cos bx. So if we compare this with this, then a is minus s and b is a. So just replace a by minus s and b by a. So here we will get e raised to minus st divided by minus s whole square plus a square in bracket minus s sin at minus a cos at, and limit will be 0 to infinite. So first of all we will replace t by infinite, so here it will be e raised to minus infinite. Okay, so e raised to minus infinite will be 0, then we will replace t by 0, so minus 1 divided by s square plus a square. So if we replace t by 0, then sin 0 is 0 and here cos 0 is 1, so here it will be minus a. So if we simplify this, then final answer will be a divided by s square plus a square. Therefore Laplace transform of sin at is given by a divided by s square plus a square. Now let us discuss Laplace transform of cos at. So Laplace transform of cos at is given by integration 0 to infinite e raised to minus st cos at dt. So here we will use this formula, integration e raised to ax cos bx dx is equal to e raised to ax divided by a square plus b square a cos bx plus b sin bx. So if we compare this e raised to minus st cos at with integration e raised to ax cos bx, then a will be minus s and b will be a. So using this formula we will get e raised to minus st divided by minus s whole square plus a square in bracket minus s cos at plus a sin at, and limit will be from 0 to infinite. So first of all we will replace t by infinite. So here we will get e raised to minus infinite. So e raised to minus infinite is 0. So answer of upper limit will be 0. Then minus lower limit. So for lower limit we will replace t by 0. So here we will get e raised to 0. So e raised to 0 is 1. So 1 divided by s square plus a square, and value of cos 0 is 1 and sin 0 is 0. So here it will be minus s. So if we simplify this, then we will get s divided by s square plus a square. Therefore Laplace transform of cos at is equal to s divided by s square plus a square. Now let us discuss Laplace transform of sin hyperbolic at. So Laplace transform of sin hyperbolic at is given by integration 0 to infinite e raised to minus st sin hyperbolic at dt. So we know that sin hyperbolic at is defined as e raised to at minus e raised to minus at divided by 2 into e raised to minus st dt. Okay, so if we simplify this, so 1 by 2 is common, in bracket integration 0 to infinite e raised to minus in bracket s minus a t dt minus integration 0 to infinite e raised to minus in bracket s plus a t dt. Now integration of this term with respect to t will be e raised to minus s minus a t divided by minus in bracket s minus a, because coefficient of t is minus in bracket s minus a, and limit will be 0 to infinite. Same way here integration of this term with respect to t will be e raised to minus in bracket s plus a t divided by minus in bracket s plus a, because here coefficient of t is minus in bracket s plus a, and limit will be from 0 to infinite. So here if we simplify this, first of all we will replace t by infinite. So e raised to minus infinite will be 0. Then minus lower limit. For lower limit we will replace t by 0. So e raised to 0 will be 1. So answer of this term will be 1 divided by s minus a. Same way here, first of all we will replace t by infinite. So here it will be e raised to minus infinite. So e raised to minus infinite is 0. Then minus lower limits. For lower limit we will replace t by 0. So e raised to 0 is 1. So here it will be 1 divided by minus s plus a. So final answer of this term will be 1 divided by s plus a. So if we simplify this, then it will be s plus a minus s plus a divided by s minus a into s plus a, which can be written as s square minus a square. Okay, so here s cancel out, so a plus a is 2a and 2 is also cancel out. So final answer will be a divided by s square minus a square. Therefore Laplace transform of sin hyperbolic at is given by a divided by s square minus a square. Now we will discuss Laplace transform of cos hyperbolic at. So Laplace transform of cos hyperbolic at is given by integration 0 to infinite e raised to minus st cos hyperbolic at dt. Now we know that cos hyperbolic at is defined as e raised to at plus e raised to minus at divided by 2. So here if we simplify this, then here it will be integration 0 to infinite e raised to minus in bracket s minus a t dt plus integration 0 to infinite e raised to minus in bracket s plus a t dt, and 1 by 2 is common. Now if we take integration of this term with respect to t, then it will be e raised to minus in bracket s minus a t divided by minus in bracket s minus a, because here coefficient of t is minus in bracket s minus a, and limit will be 0 to infinite. Same way, here integration of this term with respect to t will be e raised to minus in bracket s plus a t divided by minus in bracket s plus a, because their coefficient of t is minus in bracket s plus a, and limit will be 0 to infinite. So here if we simplify this, then we will get 1 divided by s minus a, and if we simplify this, then here we will get 1 divided by s plus a. So again, taking LCM, here we will get s plus a plus s minus a divided by s minus a into s plus a. So here a cancel out, and s plus s is 2s, and 2 is also cancel out. So final answer will be s divided by s square minus a square. Therefore Laplace transform of cos hyperbolic at is given by s divided by s square minus a square. Now let us discuss examples. First example, find the Laplace transform of function 0 where 0 less than t less than pi and sin t for t greater than pi. So by definition of Laplace transform of f of t is given by integration 0 to infinite e raised to minus st ft dt. Here we have to split this function according to the limit. So integration 0 to infinite can be written as integration 0 to pi e raised to minus st into 0 dt plus integration pi to infinite e raised to minus st into sin t dt. Here we have written value of function is 0 because in this limit f of t is 0, and here we have written f of t is equal to sin t because for this limit f of t is sin t, because f of t is sin t for t greater than pi. So here again we will use this formula integration e raised to ax sin bx. So it will be e raised to ax divided by a square plus b square in bracket a sin bx minus b cos bx. So here we have to replace a by minus s and b by 1. So here it will be e raised to minus st divided by minus s whole square plus 1 square in bracket minus s sin t minus cos t, and limit will be pi to infinite. So first of all we will replace t by infinite. So here it will be e raised to minus infinite, and e raised to minus infinite is 0. Then minus lower limit. So for lower limit we have to replace t by pi. So here it will be e raised to minus pi s divided by s square plus 1 minus s sin pi minus cos pi. We know that value of sin pi is 0 and value of cos pi is minus 1. So if we simplify this term, then it will be minus e raised to minus pi s divided by s square plus 1. So this is Laplace transform of this function. Now let us discuss second example. Find the Laplace transform of 1 divided by root t. So by definition of Laplace transform, Laplace of f of t is given by integration 0 to infinite e raised to minus st ft dt. So here we have to find out Laplace transform of this function. So we will replace f of t by 1 divided by root t dt. So integration 0 to infinite e raised to minus st t raised to minus 1 by 2 dt, because 1 by root t can be written as t raised to minus 1 by 2. Now suppose st is equal to x. So dt will be dx by s and t will be x divided by s. Now we have to check that whether limits are changing or not. So when t equal to 0, then x is also 0, and when t is infinite, then x is also infinite. So limits will be same from 0 to infinite. So integration 0 to infinite e raised to minus st into t raised to minus 1 by 2 dt can be written as integration 0 to infinite e raised to minus x, because st is x, and in place of t we can write down x divided by s. So here x divided by s whole raised to minus 1 by 2, and in place of dt we will write down dx divided by s. So here into dx divided by s. Now here s raised to minus 1 by 2 into s raised to 1 will be a constant. So this can be written as 1 divided by root s, because s raised to minus 1 by 2 plus 1. So it will be s raised to 1 by 2. So this can be written as 1 divided by root s integration 0 to infinite e raised to minus x into x raised to minus 1 by 2 dx. Now by definition of gamma function, this can be written as gamma of minus 1 by 2 plus 1. So this will be gamma of 1 by 2 divided by root s. Now gamma of 1 by 2 is root pi. So we will replace gamma 1 by 2 by root pi. So it will be root pi divided by root s. So final answer is in under root pi by s. So this is the Laplace transform of function 1 divided by root t. So in this lecture we have discussed about Laplace transform and Laplace transform of elementary functions. Thank you for watching this video.